Download this code from codegive.com, link in the description below. Google extends Linux kernel support for Android, an informative tutorial. In recent years, Google has made significant strides in extending the Linux kernel support for Android devices. This effort ensures that Android runs smoothly on a wide variety of hardware and takes advantage of the latest enhancements in the Linux kernel, such as improved performance, security, and power management. Overview of Linux kernel support for Android. 1. Kernel updates. Google regularly updates the Android kernel to incorporate the latest features and security patches from the mainline Linux kernel. This helps to improve performance and security while also ensuring compatibility with new hardware. 2. Mainline versus Android kernel. The Android kernel is based on the Linux kernel but is optimized for mobile devices. Google works closely with various hardware manufacturers to ensure that the Android kernel can support a wide range of devices. 3. Long-term support, LTS. Google also supports long-term stable versions of the Linux kernel for Android. This means that certain kernel versions receive updates for extended periods, allowing manufacturers to provide a stable environment for their devices. 4. Community contributions. Google encourages contributions from the open source community, which helps enhance kernel features and fixes. Developers can submit patches and improvements that benefit all Android devices. Key features of Google's extended Linux kernel support. Security enhancements. Regular updates keep devices secure against vulnerabilities. Performance optimization. Features like CPU frequency scaling and memory management improvements help devices run more efficiently. Device compatibility. Support for a wide range of hardware ensures that Android runs on various devices, from smartphones to IoT devices. Power management. Advanced power management features help extend battery life. Example, kernel module development for Android. To illustrate how developers can contribute to the Linux kernel for Android, let's walk through a basic example of creating a kernel module. This module will log messages to the kernel log whenever it is loaded or unloaded. Step 1. Setting up your development environment. To get started, you will need a Linux environment. Ubuntu is commonly used. The Android NDK, Native Development Kit, installed. Kernel source code for your Android device. You can obtain the kernel source code from the manufacturer's website or from the Android Open Source Project, AOSP. Step 2. Writing a simple kernel module. Create a file named hello_android.c. Step 3. Compiling the kernel module. You will need to set up a makefile to compile your kernel module. Run the following commands in your terminal. This will compile the hello_android.c file into a kernel module, hello_android.ko. Step 4. Loading and unloading the module. You can load and unload the kernel module using the following commands. Step 5. Testing. After loading the module, you should see the message "Hello, Android kernel" in the kernel log. When you unload the module, you will see "Goodbye, Android kernel." Conclusion. Google's ongoing efforts to extend Linux kernel support for Android bring numerous benefits, including enhanced performance, security, and device compatibility. By contributing to the kernel through development, developers can play a crucial role in the Android ecosystem. The simple kernel module example provided showcases how straightforward it can be to start contributing to the Linux kernel for Android devices. Additional resources. Android Open Source Project, https://source.android.com. Linux kernel documentation, https://www.kernel.org/doc/html/latest. Kernel newbies, https://kernelnewbies.org. Feel free to explore these resources to deepen your understanding of Linux kernel development for Android.